This is the readout for chapter 1.5 on cosine law. In this chapter, we'll determine missing side lengths and angles in oblique triangles using the cosine law. In the previous chapter, we worked with the sine law and we solved side lengths and angles in oblique triangles. Once again, that's triangles without a right angle. The cosine law does the same thing, but given a different circumstance. The cosine law for an oblique triangle ABC reads as c squared is equal to a squared plus b squared minus 2 multiplied by a and b and then multiplied by cos of c. This is a larger equation to find the value of a side length, which is labeled c here. Just like the sine law, there are two versions of it. The first version has the side length lowercase c isolated. The second version is used to find an angle. It can be rearranged to the second version, which is cos of angle c is equal to a squared plus b squared minus c squared, all divided by 2ab, or 2 times a times b. Now, what cosine law is used for is to solve for side lengths in an oblique triangle when we cannot use the sine law. To use the sine law, we had to have a matching angle and side combination, because recall the sine law was sine A over A is equal to sine B over B, which is equal to sine C over C, or the reciprocated flipped version of that. A over sine A is equal to B over sine B is equal to C over sine C. In any case, we needed a matching combination of an angle and its corresponding side. Cosine law allows us to solve a triangle when we don't have that situation. Two situations occur where cosine law is used. The first we examine in case 1, and this is the side angle side case, or SAS. We use cosine law to solve a triangle side lengths if we have a side length, an angle, and then the next side length as well. In this case, this triangle example, we're given the side length of Z, which is 8 meters, angle Y at 50 degrees, and side length lowercase x, which is 7 meters. Now in this case, we don't have any matching combinations. We have side Z, but we don't have angle Z. We have angle Y, but we don't have side Y. And we have side X, but we don't have angle X. Because we don't have any matching combinations, we're not able to use the sine law. Instead, we have to use cosine law. The question asks, find the length of Y. We'll set up our cosine equation. Instead of c being the isolated variable, or c squared, we're looking for y, or y squared. So the given equation in general form, c squared is equal to a squared plus b squared minus 2ab cos c. We will sub in our pieces of information. We're looking for y squared, so that will be alone on the left-hand side of the equation. A squared and b squared will be the two other side lengths. In this case, that's z squared and x squared. Now, it actually doesn't matter what order you write them. If you want the 8 meters to be a squared or b squared, that won't make a difference. In this case, let's let z represent side length a. So a squared, let's input 8 meters squared. And b squared, the other side length, will be 7 meters squared. Minus 2 times a times b, minus 2 multiplied by 8 multiplied by 7, and then cos of the angle. In this case, that's angle y, which is 50 degrees, so cos of 50. And we will need a calculator to do this. Now be careful doing this line of calculating from what we just wrote to the answer. If it takes more than one step, that's fine. If you are confident in putting the whole thing into your calculator, that works as well. This in a calculator should come out to evaluate to 41.0. So y squared is equal to 41.0. We are asked to find just y, Our last step is to do the opposite of squaring y, and the opposite of squaring is square root. So taking the square root of 41.0 gives us a final answer for y of approximately 6.4, and the units on that will be meters. So to use cosine law, find what you are asked to solve, write the starting version of cosine law, input the values, then on a calculator evaluate the large right hand side. Finally, to go from having y squared to just y, or whatever variable you are trying to solve, take the square root and that will be your final answer. Let's check to see if this looks reasonable in the context of the diagram. Is 6.4 meters a reasonable length for y? Yes, it is. If your answer was much larger or much smaller, if you had an answer of 82 or 105 or something much larger, and you look at the triangle and you think that cannot reasonably be the correct answer, then make sure to go back and check your work and see if an error was made somewhere. But 6.4 is a pretty reasonable length for this diagram for length y. The second case for cosine law to solve an oblique triangle is if we're given no angles but instead all three side lengths, the side, side, side case, SSS. In triangle PQR, find angle Q. When using cosine law to solve for an angle rather than a side, we will use the second version of the equation. So let's start by just writing the equation as is. Cos of C is equal to a squared plus b squared minus c squared, divided all by 2 times a times b. We're asked to find angle Q. Now, from the original version of cosine law, that will be our angle C. So the left-hand side, instead of cos C, let's input that variable of Q. So cos of angle Q is what we are trying to find. Now, because we were looking for Q, the C in the original equation has to be the length of, well, Q in this case, on our triangle. So our length of C, or length Q, is 56.5 meters. That leaves A and B in the equation to be the other two legs of the triangle, the 34 meters and the 35 meters. So inputting C, A, and B into our equation for the cosine of Q, or C for the angle, we generate the equation 34 meters squared plus 35 squared subtract 56.5 squared, we will have to square all of those, divided by 2 times a times b will be 2, multiplied by 34, multiplied by 35. So taking our three side lengths a, b, and c and inputting them. Now, there is some calculator work to be done between this line and the next. I would recommend taking it in 2 steps, squaring all the numbers in the numerator first, follow BEDMAS, then add and subtract, then divide by the value on the denominator. Taking it in 2 steps, or if you're careful, all in 1 step on a calculator, should bring the left hand or the right hand side rather to show a value of negative 0.3409. That's the value of cos of Q. We're asked to find angle Q itself. So our final step, what is the opposite of taking the cos of Q? Well, the opposite of cos is the cos inverse. So on a calculator, let's take the cos inverse of negative 0.3409, and doing so should give us a value of 110 degrees, approximately. The angle Q, found using cosine law, is 110 degrees. Does that look like a reasonable angle on a triangle? Is this close to 110 degrees, estimating the diagram? Yes, it is. So cosine law. has two versions, one used to find the side length, one used to find a missing angle, and is used whenever we can't use sine law. That's used whenever we don't have a matching side and angle combination. The two cases being if we have side, angle, side, or all three side, side, side. So that's it for 1.5 cosine law. The practice questions are below. Use the sample examples to help with those. And as always, solutions are below.